Problem set 1 is based on the unit and dimensions. First question is, the dimension of the quantities in one or more of the following pairs are same. Identify the pairs. First pair is torque, which is defined as the cross product of position vector and the force, and its unit is Newton meter, while the work is defined as dot product of force and displacement, and its unit is also Newton meter. Therefore, the dimensions of these will be same. So option A is correct. Another is angular momentum, which is the cross product of position vector and the momentum, and unit will be kilogram meter square per second, and work is Newton meter, or we can write it as kilogram meter square per second square. As unit are not same, so dimension will not be same. So B is not the correct option. Option C is energy. Energy has same unit as of the work, so its unit is kilogram meter square per second square, while Young modulus is defined as stress by strain. Strain is unitless, so it has same dimension as that of the stress. Stress is force by area, so its unit will be kilogram per meter per second square. Because units are different, so their dimensions will be different. So option C is also not the correct option. Option D is light year. Light year is the distance covered by the light in 1 year, so its unit is meter. Wavelength is the distance between two consecutive crusts or two consecutive troughs in a transverse wave. So we can say it is also measured in meter because units are same, so their dimension formula will be same. Hence option D is the correct option. Hence A and D are the correct option. The pair of physical quantities that have same dimension age are option A is the Reynolds number. Reynolds number is the number which is the measure of the turbulence in the flow of liquid. So it is a unitless. Similarly, coefficient of friction is also unitless. Hence, option A is the correct option. Option C is Curie. Curie is the rate of disintegration. That means disintegration per unit time. Hence, its unit is per second. Frequency is also having the unit of per second. Hence, option B is also the correct option. Latent heat and the gravitational potential. Latent heat is defined as the heat per unit mass, while the gravitational potential is defined as the gravitational potential energy per unit mass. As both units are energy per unit mass, so they have same dimensions. So option C is also correct statement. And in D, Planck's constant H, which is E by nu, and its unit will be kilogram meter square per second square for energy and per second for the frequency. Therefore, its unit is kilogram meter square per second. While the torque, which is defined as R cross F, that is position vector, and the force, it has the unit kilogram meter square per second square. Therefore, unit are different, hence dimensions will also different. Hence option A, B, C are correct options. Second question is, which of the following sets have different dimensions? First is pressure. Pressure is defined as force per unit area. Young modulus, it is defined as stress by strain. Strain is dimensionless, so Young modulus have the same dimension as of stress, and stress is force per unit area. And stress, as said earlier, it is force per unit area. So these have same dimension and not correct as per the question. Part B is also having the EMF potential difference and electric potential having same unit, so same dimensions. Heat, work done, and energy, they are having the same unit and same dimension. So A, B, C are not the correct answers for the question 2. In part D, dipole moment P is the product of charge and the separation between the charges. So its unit is coulomb meter. Electric flux is the product of electric field and the area, while electric field is the force per unit charge. So we can see that these have the different units. So this option D is the correct option as per the question. Third question is, what is the dimensions of the following? We are giving here the related formula. You have to calculate the dimension yourself. First part is epsilon naught, that is the permittivity of free space. So we can use formula force equal to 1 by 4 pi epsilon naught q square by r square. Second is mu naught, that is the permeability of free space. After calculating the epsilon naught, we can easily calculate the mu naught by using the formula C equal to 1 by square root of mu naught epsilon naught. Part C is the energy density. That means it is energy per unit volume. So it can be easily calculated as ml2 T minus 2. It is the dimensional formula of the energy divided by L cubed. It is the dimensional formula of the volume. So we can write that it is ml minus 1 T minus 2. In part D, as we have mentioned here in B, that C equal to 1 by mu naught epsilon naught. So we can write that square root of mu naught epsilon naught is equal to 1 by C, or mu naught epsilon naught will be equal to 1 by C square. So its dimensional formula will be L minus 2 T2. Magnetic flux is phi equal to integral B dot ds, or we can also write at E equal to minus n d phi by dt. Using this, we can calculate the dimensional formula of flux. F is modulus of rigidity, which is calculated by eta, that is equal to stress by strain, and stress is force by area and strain is dimensionless. So we can say it is ml minus 1 t minus 2. Part G is the Planck's constant. We know E equal to h nu, it is the energy of the photon. So Planck's constant E equal to h by nu. E is having the dimensional formula ml2 t minus 2 divided by frequency f dimensional formula t minus 1. So dimensional formula of Planck's constant will be ml2 t minus 1. And this have the same dimensional formula as that of the angular momentum, which is given by r cross p. Here dimensional formula of R is L and P is MLT minus 1. So it will give ML2 T minus 1. And in H part, electrical conductivity. Conductivity is inverse of the resistivity, and resistivity has a relation with R equal to rho into L by A, and R has a relation between voltage and current. So using this formula, we can calculate the electrical conductivity. And in HI, it is E by V. E by B is the speed of electromagnetic wave. So it has the dimension formula of Lt minus 1, that of speed. The SI unit of number A, Young modulus, which is the ratio of stress and strain. Strain is unitless, so have the same unit that of stress, which is defined as force per unit area. So its unit is kilogram per meter per second square. In option B, magnetic induction, which is related with force as ILB. Therefore, B will be equal to F by IL. F is kilogram meter per second square. I is ampere and length is meter. So meter and meter get cancelled. So we can say unit is kilogram per second square and per ampere. Option C is power. Power is inverse of the force focal length in meter. So it has the unit per meter. And inductance L can be written in many forms. One of the forms, say, energy stored in the inductor is half Li square. Therefore, we can say L has the unit as joule per ampere square, or we can write it is kilogram meter square per second square per ampere square, or it is kilogram meter square S minus 2 A minus 2. Fifth question is L, C and R represent the physical quantities inductance, capacitance and resistance respectively. The combination which have the dimension of frequency are. For electrical circuit containing resistor, capacitor and inductor, some formulas are important, that are tau referring the time constant is RC for RC circuit. This tau equal to L by R for LR circuit, and frequency omega for LC circuit is 1 by root LC. So dimension of frequency in case of LC circuit is 1 by root LC. It has dimension of frequency, that means per second. In LR circuit, the dimension of frequency will be of the formula R by L, and in RC circuit, dimension of per second will be for 1 by RC. Hence, option A, B and C are the correct option. Sixth question is, the equation of state of a real gas is given by P plus A by V square into V minus B equal to RT, where P, V, T are pressure, volume and temperature respectively. R is the universal gas constant. The dimensions of the constant A in the above equation is P plus A by V square into V minus B equal to RT. Here we know that the quantities having the same dimensions will be added. So the quantity A by V square have the same dimensions as that of the pressure. Therefore, A will have the dimension of that of pressure into volume square. Therefore, to find the dimensions of the constant A, we have to find the dimension of pressure, which is, we know that it is ml minus 1 T minus 2, and pressure of volume is L3, so it will become L6. So finally we can say A has the dimension ml raised to the power 5 and T minus 2. A gas bubble from an explosion under the water oscillate with temperature T proportional to P raised to power A, D raised to power D and E raised to power C, where P is the static pressure, D is the density of water, E is the total energy of the explosion, and find the value of A, B, C. It is given that period is proportional to P raised to power A, D raised to power B and E raised to power C. So in terms of dimension, we can write dimension formula of time period is T. It is equal to pressure is ml minus 1 T minus 2 raised to power A. Density is defined as mass per unit volume, so it will be m L minus 3 raised to power B, and energy is ml2 T minus 2 raised to power C. So it can be written as m raised to power 0, L raised to power 0, T raised to power 1 is equal to m raised to the power A plus B plus C. L raised to the power minus A minus 3B and minus plus 2C. And in terms of time period, it is minus 2A minus 2C. On comparing, we will have A plus B plus C equal to 0. This is equation number 1. Minus A minus 3B plus 2C equal to 0. It is equation number 2. And minus 2A minus 2C equal to 1. This is equation number 3. So from equation number 3, we can write A plus C is equal to minus 1 by 2. Now on subtracting the equation 3 from 1, we will have A plus B plus C minus A plus C will be equal to 0 minus minus 1 by 2. A and C get cancelled. So this implies that B equal to 1 by 2. This is our equation number 4. Now we substitute the value of 4 in equation number 2. We will have equation number 2 will become minus A minus 3 into 1 by 2 plus 2C equal to 0. This implies that minus A plus 2C equal to 3 by 2. This is equation number 5. Now we use the equation number 3 and 5 to get the value of A and C. A plus C from equation number 3 is minus 1 by 2 and minus A plus 2C is equal to 3 by 2 from equation number 5. Add them, we will have 3C is equal to minus 1 by 2 plus 3 by 2. It will give 2 by 2, that is equal to 1. So this implies that C is equal to 1 by 3. And we put the value of C in above equation. We will have A plus 1 by 3 equal to minus 1 by 2 from this equation. And this will give A equal to minus 1 by 2 minus 1 by 3. On taking LCM, it is 6 and it is minus 3 and then minus 2. So it is minus 5 by 6. Hence, A equal to minus 5 by 6, B equal to, we have 1 by minus, this is 1 by 2 and C is equal to 1 by 3. This is the answer. Eighth question is, in terms of potential difference V, electric current I, permittivity epsilon naught and permeability mu naught, the speed of the light C, the dimensionally correct equations are. For this question, we have to remember two important formulas, that is speed of light C equal to 1 by square root of mu naught epsilon naught and resistance R is equal to square root of mu naught by epsilon naught. And we know that V equal to IR from the Ohm's law. Therefore, in first option, we are given mu naught I square equal to epsilon naught V square. So we can write mu naught epsilon naught equal to V square by I square. V by I is R, so it is R square, and mu naught by epsilon naught from formula number 2, we can say it is also R. So option A is correct option. In option B, it is given that mu epsilon naught I equal to mu naught V. So we can write that mu naught by epsilon naught into V by I equal to 1. This implies that the mu naught by epsilon naught have the dimension of R square, and Vi also have dimension of R square. It is not 1, so it is not a correct answer. Option C is giving I equal to epsilon naught CV. This can be written as 1 equal to C into epsilon naught into V by I. This V by I have the dimension of R. So it is 1 equal to C is having the formula square root of mu naught epsilon naught into R. So 1 is dimensionally equal to, here epsilon naught will get cancelled, so it will be square root of epsilon naught by mu naught into R. Because square root of mu naught by epsilon naught is R, so we can write it is 1 equal to 1 by R into R. So dimensionally it is correct formula. So option C is also correct. And similarly, we can check that option D is not correct. Hence A and C are the correct option. Ninth question is, if speed v, acceleration a, and force F are considered as fundamental units, the dimensions of Young modulus will be. It is given that Young modulus depends on velocity with raised to power a, acceleration raised to power b, and force raised to power c. So we have to find the ABC. This can be dimensionally written as, this Young modulus is having the dimension as of force by area, so we can write it as ml minus 1 t minus 2 equal to dimensions of velocity or speed is lt minus 1, so it is raised to power a. Acceleration is lt minus 2 raised to power b, and force is ml t minus 2 raised to power c. Now we can write it as ml minus 1 t minus 2 equal to, here m raised to the power c, l raised to the power a plus b plus c, and t raised to the power minus a minus 2b minus 2c. Now when comparing, we will have c equal to 1. Then a plus b plus c, which is the dimension of length, will be equal to minus 1, and dimensions of time will be minus a minus 2b minus 2c is equal to minus 2. So from equation number 1, we can put the value of c in equation number 2 and 3, and we will have a plus b plus 1 equal to minus 1. This implies that a plus b equal to minus 2. This is equation number 4. From third, we can write minus a minus 2b and minus 2. C is 1 equal to minus 2. This implies that minus a minus 2b is equal to minus 2 plus 2 equal to 0. So it is a plus 2b equal to 0. This is equation number 5. So using equation number 4 and 5, we can subtract equation 4 from 5. It will give a plus 2b minus a plus b equal to 0 minus minus 2. This implies that a and a get cancelled. So it will be 2b minus b, that is b equal to 2. This is equation number 6. And now substitute the equation b in any of the 4 and 5. We will have from equation 4, it will be a plus 2 equal to minus 2. This implies that a equal to minus 4. It is equation number 7. So now substituting the value of ABC, we will have the Young modulus have the dimension of v raised to the power a is minus 4, then a raised to the power b is 2, and f raised to the power c is 1. This is the answer, so option D is the correct option. 10th question is, the force of interaction between two atoms is given by F equal to alpha beta exponential minus x square by alpha kt. We have to find the dimension of beta. Formula is F equal to alpha beta into e raised to power minus of x square by alpha kt. We know that this power will be a unitless number. So x square have the same unit as of alpha kt. or we can say alpha has the same unit or dimensions as that of the x square by kt. Here, this force will have the same dimension as that of the alpha beta because exponential term will be a unitless number. Therefore, we can say that dimension of beta will be same as of f by alpha, or we can write it is f by x square by kt, or it can be written as f by x square into kt. This kt term has the dimensions of energy because we know that energy per unit dimension per molecule per dimension is 1 by 2 kBt, where kB is the Boltzmann constant, is the temperature. So we can write that dimension formula of force is mLT minus 2, and that of energy is mL2T minus 2, and x is the distance, so it is L2. This L2 get cancelled, so we can write it is m2 Lt minus 4. Hence option C is the correct option.